Dion has two bunches of similar bananas. One bunch had 8 bananas, the other bunch has 9 bananas. 6 foot, 7 foot, 8 foot bunch. The list below shows the weight in grams of each of the bananas in the bunch of 8. Which measurement is most likely closest to the total weight of the bunch of 9? All right, so we have to add all these up. I'm assuming this is for a calculator section, so let me pause and find out what all of these added up together are. All right, so according to Siri, when you add all 8 of these together, you get 1,048. So these guys are similar. If you wanted to find the average, you would divide that by 8. So you're looking at like 100 some. What's 1,048 divided by 8? I'm using Siri. 131. So if 8 of them cost about that much, then the average banana being added to a bunch of 8 to get you 9 is looking at 1,179, which is C. Strange problem. So many bananas. B-A-N-A-N-A-S. Gwen Stefani. Vaughn surveyed 9 classmates. He asked each classmate for the number of days in the previous week that he or she had eaten fruit and the number of days that they had exercised. The scatter plot below shows the results of his survey. So, like that point right there says that this person ate 5 days of fruit, but only exercised twice. You're the outlier. What is the median number of days that the 9 classmates exercised last week? Okay, so let's look at the exercised. And you had one person who exercised 1 day. You had one person who exercised 2 days. You had 2 who exercised 3. So let's write out 3. You had 1 who exercised 4. You had 1 who exercised 5. You had 2 who exercised 6, so 6 and 6. And then you had 1 who exercised 7 days. I want the median, which is the middle. So small, big, small, big, small, big, small, big. So the median days of exercise is 4. The answer is C. What a weird problem. I didn't like it. A bookstore manager will randomly select one of 5 newly arrived fiction books and one of 4 newly arrived non-fiction books for a window display. What is the probability that the manager will select the shortest of the newly arrived fiction books and the longest of the newly arrived non-fiction books? All right, so let's, 1 of 5 fiction, let's let that be the black pen. So the probability that the one that you choose is the, what do they want, the shortest? The shortest of the fiction books is going to be 1/5. The probability of the nonfiction books being the longest is going to be 1/4. When you have multiple probabilities going on, compound probabilities, you multiply those together. 1 times 1 is 1. 5 times 4 is 20. 1/20 is the same as 5%. And that's your answer there. The scatter plot below shows the relationship between the time in minutes and the distance in miles that Julie walked on several occasions. All right, so basically we have a scatter plot, line of best fits glued on it. So one day Julie went out and walked for about 15 minutes and walked for a little over a mile. And one day Julie walked for 55 minutes and walked for 4 miles, stuff like that. based on the line of best fit, which is most likely the number of miles Julie would walk in 105 minutes. So basically what I need to do is I need to pretend that this line is still going. And given the fact that I have a track record of never being able to draw straight lines on this thing, I nailed it. Okay, 105 minutes is going to be this dot up here that's not even on the graph. But that dot up there, I can use a little bit of, estimation and say that dot up there would be a 7 if the graph kept going. So 7 it is. I'm sticking with it. 105 minutes should be around 7 miles if using this line of best fit as an estimate. The box and whisker plot below represents the prices of all the cars for sales at a dealership. All right, so price in thousands of dollars. So basically you have all these cars. One car costs $6,000, another car costs $25,000, and a bunch of cars in between. And the median car, which means if you were to list all the cars up in a row, least expensive to most expensive, the one right in the middle is going to be $12,000. Many of the cars live in between 10 to 14,000. In fact, 50% of them do. Stuff like that. This is a box and whisker plot. And just basically looking at this when it talks about 1/2, 1/4, all, you're going to chop this up into 4 quarters, okay? This is going to be 25%. So 25% of the cars are going to be in between $6,000 and $10,000. Another 25 is going to be in between $10,000 and $12,000. Another 25% is going to be in between $12,000 and $14,000. And another 25% is going to be in between $14,000 and $25,000. So let's see what it's asking us. Based on the box and whisker plot, which statement about the prices of the cars is most likely to be true? 1/2 of the cars are priced at $12,000. Well, that's not true. I would say now the $12,000 is the median. That doesn't mean it's 1/2 the cars. In fact, it's impossible. But half of the cars are less than 12,000 and half of the cars are more than 12,000, but half of them aren't 12,000 on the dot. That's not true, or that's not most likely true. All the cars are priced no lower than $10,000. Well, that's not true at all because the lowest priced car is $6,000. So that doesn't make sense. 1/2 of the cars are priced between $14,000 and $25,000. $14,000 is here, $25,000 is here, but 25% of the cars are priced between that, not 1/2. So this one's got to be true. 1/4 of the cars are priced between 12 and 14. Here's 12, here's 14. That makes 25%. D is the answer. Box and whisker plots. The bar graph below shows the average number of minutes Frank spends each week participating in 4 activities. All right, let's see what Frank's into. Frank likes to play games online. He likes to play sports. He likes to read. And he likes to social network, like a TikTok. Based on the information shown in the bar graph, which value is most likely the difference between the number of minutes Frank will spend reading the next 4 weeks and the number of minutes Frank will spend gaming online in the next 4 weeks. All right, so there's a little bit of trickery here. And the trickery is these phrases. It doesn't say week. See, this is Frank's weekly activities. So this is the challenge that you have to do. Yeah, we care about what happens with reading, and reading appears to be 175. And yeah, we care about Frank gaming online, which appears to be 120 maybe, because it's right below the line. So we'll say 120. So every week he spends 175 minus 120 more than, which is 55. Right? That's per week. This problem isn't asking for per week. It's asking for 4 weeks. So every week is 55, but every 4 is 220, which is awfully close to 224. So the actual number probably should have been 56, but how am I supposed to know that by looking at that? It's a prediction. Yeah, I like that. It was, you really have to read that carefully. I think most people would put A if they don't read this carefully because they're like, oh, difference. I know what that means. That means minus that, minus that. And that makes sense, but you're not done with that. Tricky, tricky, tricky. A teacher measures the time it takes each student in a class to complete a puzzle. The first quartile value of the teacher's data is 4 minutes. The third quartile value is 6 minutes. Which statement must be true? So when they mention quartiles, they're talking about the grand world of box and whisker plots. Now, a box and whisker plot is split up into 4 parts. 1, 2, 3, 4. Each of those parts make up 25% of your data. So basically, this teacher is timing every kid. They say, on your mark, get set, go. And they're like, oh, you got it done in 3 minutes, and you got it done in 4 minutes, and you got it done in 10, blah, blah, blah. And they take all that data, and they make a chart out of it. Well, quartile 1 is this chunk right here. That's quartile 1, and they say 4 minutes for that. Quartile 3 is that chunk right there. They say 6 minutes for that, which means in between quartile 1 and quartile 3, you've got 50% of your data happening. So anything below 4 is 25%. Everything in between 1 and 3 is 50%, and everything bigger than 6 is 25%. So let's see what they want. About 25% of the students completed the puzzle in 4 minutes or less. That's actually true. So yeah. About 50% of the students completed the puzzle in 6 minutes or more. Nope, that would be 25. That should be 25. Exactly 25% of the students completed the puzzle in exactly 4 minutes. Well, we don't know that. That's just kind of like a median type number, but a median for the lower half. And exactly 50% of the students completed the puzzle in 5 minutes or less. I don't know that. Now, it's tempting. It's tempting to say that that is true because you might be thinking, well, that's 4 and that's 6, so that number must be 5. Well, no, we don't know that. We don't know that number. It could be, but we don't know. The thing that must be true is the fact that 25% is going to be 4 or lower. Okay, so the answer is A. Kind of tricky. Not so bad, but I hate the fact that they threw in D just to mess with your heads. The scatter plot below shows the cost Y in dollars of orange trees based on their ages in years. All right, so as orange trees get older, they cost more money. Pretty basic. Based on the scatter plot, which equation represents the line of best fit for the cost of the orange trees? All right, so if you have a death wish and you have Desmos or a graphing calculator, you can plug all of these points in and use like linreg or something like that. That's too much. I'm not going to do that. I'm going to do my best to draw a line of best fit. It looks terrible already. But that's me attempting to draw a line of best fit using a pen that's connected to my computer. Now, what I'm also going to do using a different color is I'm going to say, let's predict that if I'm pretending this is slope-intercept form, which is y equals mx plus b, m is my slope, b is my y-intercept. So my b is going to be roughly around 30. So I'm not a fan at all of this picture that I drew, but I'm keeping it. I stuck with it. I'm going to continue sticking with it. If I have a dot, let's say a dot here and a dot here to predict my slope, I'm using these 2 dots. Every time I go up by 10, 20, 30, 40. So my slope is going to be 40 over. Every time I move over by 1. So 1, 2, 3, 4. So my slope is 10-ish knowing very well that it's not 10 because I kind of took 2 points that necessarily weren't exactly on the line, but I wanted to use those points to make it convenient for me when I come up with my points or with my answer. So plugging this all in, I have y equals, my m is 10-ish, x plus b, which I predicted to be around 30. The only one of these that is 10-ish x plus 30 is b. You give me the 10-ish that I want. You don't give me 10-ish. You don't give me 10-ish, and you don't give me 30. You aren't 30, but you're close. So, yeah, that's that. And every time I said 10-ish, I wanted to come up with a really good tennis pun. Couldn't come up with it. What a racket. The answer is B. Carl, or if you're a cop who fights zombies, Coral, starts biking at some distance from his house and rides his bike away from his house. The graph below shows the relationship between the amount of time Carl rides and his distance from his house. So, okay. So basically, when I see this without even looking at the question, I have a constant rate. So he's driving his bike at the same exact speed the entire time. At 0 minutes, he's already a quarter mile away from his house. And then his speed can be found by calculating the slope. Am I doing too much? Yeah, probably. But in fact, I can't even look at this and find the slope right away. Maybe that seems to cross nicely. I don't know. I'm not wearing my sunglasses. What distance in miles is Carl from his house when he starts biking? Well, that's easy. I just solved that anyway. So I don't even have to worry about speed. But yeah, that's it. 0 minutes. He's already 0.25 miles in distance. And it says up here, away from his house. So, from his house. So there you go. Pretty easy. Sonia is baking cookies. The table below shows the relationship between the number of batches of cookies she bakes and the number of cups of sugar she uses. So we've got 1, 2, 3 batches. One batch is 2 1/4. 2 batches is 4 1/12 or half. 3 is 6 3/4. So if you're noticing, this goes up by 1 every time, and this also goes up by the same number, and that same number is 2 1/4 every time. So there's a pattern that'll come in handy probably. Based on the relationship shown in the table, how many more cups of sugar does Sonia use to bake 9 batches of cookies than to bake 3 batches of cookies? So basically, we're going to take 9 batches, subtract out 3 batches, and we care about how much sugar is used for 6 batches of cookies. I've got 99 problems, but a batch of cookies ain't one. Please don't tell anyone I just did that. All right, so 6 batches. Well, every batch requires 2 1/4 cups of sugar. So 6 batches is going to be 6 times 2 1/4. I'm not a big fan of multiplying whole numbers to mixed numbers, so this is how you can turn mixed into improper. Multiply the main number times the denominator. That gives you 8. Add it to the numerator. That gives you 9, and this becomes 9 over 4. I'll just turn this into 6 over 1. And I can multiply straight across the top, straight across the bottom. And you know what I noticed? I noticed that if I have a 6 up here and a 4 down there, I can make that a 3, and I can make you a 2. So you become 20. 3 times 9 is 27. 1 times 2 is 2. And 27 over 2 turns back into 13 and a half, which is that guy. So multiple ways I could have done this. This is the way that popped into my head first. You could do proportions. You can do ratios. I liked it this way. I want it that way. Backstreet Boys. A student completes math problems at an average rate of 2 problems every 5 minutes. At this rate, how many math problems does a student complete in 65 minutes? So what I'm going to do is I'm going to set this up as a proportion. Now, some people might use common sense, but I'm just going to do a proportion because I like to live dangerously. So 2 problems every 5 minutes has to compare to, I don't know, problems every 65 minutes. I'm going to replace that I don't know with a variable, probably x. And then what I'm going to do is, since this is a proportion, I'm going to do crisscross applesauce. 5 times x is 5x. 2 times 65 is 130, so I'm going to set that equal to 130. Divide by 5, divide by 5, and x is going to equal 26. So 26 math problems. Again, a lot of you would be like, well, hold on. In order to go from 5 to 65, I multiply 13, so why don't I just multiply 2 to 13? Yep, that works, but this works too. And I wanted to show you 2 different ways, and I did. The end. B. A function of x is graphed on the coordinate plane below. All right, so y equals mx plus b, because clearly that's what they want me to do here. Which equation describes the function? So m is the slope. So I know you may have to zoom in a little bit. I'm going to pick 2 dots that appear to represent the slope. It's a positive line, so my slope appears to be going up 1, 2 over 1, 2, 3. Positive 2 over 3 is my slope. My y-intercept is where my line crosses the y-axis, which I know it's hard to see, so let me erase the slope. It appears to be -4. So now that I know that m is 2/3 and b is -4, my equation is 2/3 x minus 4. And that would be u. The end. The set of ordered pairs below is a relation. So without looking at the problem, 1, 5, 0, 2, -1, -1, -2, -4, this is a function. But that's not what it's asking me. What is the range of the relation? The range is the y values. Domain is the x. Range is the y. So 5, 2, -1, -4. It looks like they want me to put it in order. So putting it in order from least to greatest is -4, then -1, then 2, then 5, which is A. Range is y values. That's all I have to do. Don't overthink it. Which graph represents a function? Well, a function is a function if it passes the vertical line test. So that's probably the best vertical line I've ever drawn using this thing. And what you do is you take this green line and see if my green line hits my graph at more than one spot. Nope. So that is a function. And so I'm done. I didn't realize that's all I had to do. If you're wondering, well, wait a minute, let's see more. All right, let's. If I want, hold on one second. Now, if I wanted to see if B was a function, again, this line is not allowed to hit my picture more than once. So not hitting it, not hitting it. So that didn't work. So if I were to go down here, the answer is A. Like and subscribe. The table below shows a pattern in the cost of online data storage for different numbers of terabytes of data stored. How exciting. The pattern continues. Which equation describes the pattern? Blah, 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 blah. All right, so what I'll do is I'm going to form this in slope-intercept form. Y equals mx plus b. If you had a graphing calculator, you could use LinReg on this. If you had Desmos, you could use the y equals mx plus b thing. I have tons of videos on that on my YouTube if you want to check that out. But I'm just doing this without the use of a calculator because I'm not going to use one. So what I'll do is this is going to give me here my slope by finding out the pattern of each side. The left side is going to give me my x value. Now, I know it says t. I'll deal with that in a minute. The c is going to be my y. Here, I add by 1 every time. Here, I add by 75 every time. So what that does is that gives me a slope. My slope is going to be the change in y over the change in x, which is 75 over 1. Okay, so what I have so far is y equals 75 over 1, which is just 75, x plus b. Now, in order to find b, I take any one of these points and use that as an x and a y value. So I will plug that into here and do 240 equals 75 times 3 plus b. 75 times 3 is 225 plus b. Subtract 225, and that gives us a b of 15. So b is 15. So taking this guy and this guy, I can say y equals 75x plus 15. Now, I didn't use y before, and I didn't use x before. I pretended t was x, so I'm going to replace t with x, or x with t, or t with x, and I'm going to replace y with c. And there's our guy. Now, I could have answered D the moment I got to this point right here. I could have. But I just wanted to keep going for the sake of doing a problem and to get me maybe like another $1 or $2 on YouTube. A system of inequalities is shown below. So we have a system of inequalities. So what I could do is I could just throw all of this into like a graphing calculator or Desmos, but I'm not going to do that. This is what I have. I'm going to label you black, and I'm going to just kind of draw a very, 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 very basic picture of this guy. Okay, start at 3, boop. Negative slope, boop. That looks terrible, but it's 3. And I'm shading below, boop. So I have a negative inequality. I include the line, shade below. So negative slope excludes u because these are positive slopes, excludes u because these are positive slopes. It also goes through 3, which so does that, and so does that. Now, I need to figure out what this bottom equation is going to look like. I don't know if I left myself enough room, but I guess I should find out. Subtract x from both sides, minus x. That gives me 2y is greater than or equal to negative x minus 2. Divide everything by 2, everything by 2. And that gives me the inequality y is greater than, no flipping of the signs, negative invisible 1 over 2. So negative a half x minus 2 over 2, which is minus 1. So this guy is going to be the same exact slope, but going through negative 1. Now, I'm not going to draw in lines. Shade above. So I do see the everything in between, but the key here is this is going through 1. So I care about all this negative 1, sorry. I care about all the stuff shaded in between negative 1 and 3. This shows me 2, that shows me negative 1. So although this was really close, C is what I want. They gave you the negative 2 because they were hoping you'd screw this part up, but I didn't. So the answer is C. The solution set of an inequality is shown below. So this guy appears to be x is greater than or equal to 2. Now it's greater than because it's going to the right. It's or equal to because the circle is filled in. And it's 2 because, well, 2. So I need to figure out which one of these is the same exact thing. So what I'll do is I'll solve each one of these individually. See which one gives me x is greater than or equal to 2. Unfortunately, I don't have a whole lot of trickery going on here. Like I don't have any different signs. But I will say this. A and B would force me to multiply or divide both sides by a negative, which would require me to flip that sign to U, and the same thing would happen here. So I'm not going to try A or B because I know neither of those will work. Okay, now I have a hunch that if I were to do C, I'd multiply both sides by 4 and I would get negative something, which is what I don't want. So let me try D. Okay, I'm going to rewrite D. X over 4 is greater than or equal to a half. In order to get x all by itself, I'm going to multiply both sides by 4, like so. 4 times a half is 2. X is greater than or equal to 2 is exactly what I want. The answer is D. So again, it seemed like I rushed through this. This is what I did. I crossed out the ones that I knew wouldn't work. I crossed out A because I'd have to divide by a negative, which would flip the sign to the opposite side, so A didn't work. I crossed out B because I would have to do the same exact thing, multiply or divide by a negative, which means flipping the sign, so B wouldn't work. C, if I multiply both sides by 4, I would get a negative number, but I want a positive number, so C didn't work. And so I tested out D. That seemed to be the one that did work. D, dunzo funzo, hooray! Which graph shows the solution set of the inequality, the absolute value of 2x minus 7 is greater than 3? Whenever you have an absolute value and a greater than symbol, two major things happen. First off, that's a greater than. Whenever you have a greater than or a greater than or equal to, you are going to have a word or in between two other inequalities. So that's the first major thing. The other major thing is you need to split this up into two separate inequalities. The first inequality is you literally rewrite that exactly the way it is, just without the absolute value, so like so. And the other inequality is you rewrite the left side, just drop the absolute value, flip the inequality symbol, and make the right side opposite. Okay? So what we have going on here is we have two separate inequalities that we need to solve for. You solve every inequality just like a regular old equation. It's just you have to remember, if you divide or multiply by a negative, you flip the sign. I don't think that's going to happen here, so I'm just going to add 7, cross U out. That gives you 2x is greater than 10. Divide by 2, which is a positive, so no flipping of the signs. X is greater than 5. The other inequality, we solve it using basically the same exact techniques. Add 7, cross U out. You get 2x is less than 4. Divide both sides by 2. Divide both sides by 2. No flipping of the signs. X is less than 2. Now again, the word that was in between was or. So basically you're saying I care about all the stuff that's greater than 5 or all the stuff that's less than 2. So since it's an or, you're allowed to have two separate inequalities on the same number line. So one of those inequalities is going to be x is less than 2, which means you put a circle at 2, go to the left. This is x is greater than 5, which means you put a circle at 5, go to the right. Neither of these fill in because you're not including it. So this seems to be the one that I want right here. This is everything in between. This is a negative 5, positive 5. That's a negative 5, positive 5. Everything in between. A is going to be my guy. All right, we've got ourselves a constructive response problem. In a science experiment, a scientist records the wavelengths of 6 waves. The wavelengths in nanometers are listed below. Boom, 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 boom. Which two wavelengths are equal to one another? Whenever I have to deal with different forms of numbers, I like to view them all in terms of decimals. So what I'm going to do is I'm going to turn U, and U into a decimal. So I have 5 100ths, right? And I literally am going to write that out as 5 100ths. So this is the tenths. This is the hundredths. 5 100ths looks like that. Right there. Okay? Next guy, 10 to the negative third can also be written as 1 over 10 to the third, which is 1 over 10 times 10, 100, times 10, 1,000. So I have 1 1,000ths. Okay, so 1/10th, 100th, 1 1,000ths look like that. Looks like that. 0.001. All right, you're already a decimal. I'm not going to change you. I'm not going to write you off to the side because you're 1 1,000th. Oh, how about that? 0.001. And you are written in scientific notation. So I will just say, okay, well, here's 2. I'm going to pretend that there's a decimal right there. 10 to the negative second means I'm going to move to the left 1, 2 times. Put a 0 there and fill in that space with the 0. So I have 0.02. So my two guys that are exactly the same are U, green, and U, blue. When I write them out, I'm going to write them out in their original form. So 10 to the negative third and 1 1,000th. Like that. Okay? Don't have to show any work. Don't have to do anything. Just answer the problem. Donezo. Part B. Which wavelength is the shortest? So let me go back to my original. The shortest is going to have the smallest number. So it looks like it's going to be that guy right there. That's 1/10,000th. So definitely not you. Definitely not you. You have a 1 attached to everything. So that's how they're going to try to trick you. That's actually the largest. So it's going to be 1/10,000th. So 0.0001. So let me go back here. Apparently an angel got its wings. 0.0001. Yeah, there you are. I copied and pasted it, so I'm in good shape. No work to show. It gave me all that space for nothing. All right. To find the speed of a wave, the scientist uses the formula shown below. Speed equals wavelength times frequency. The wave with wavelength x to the negative third nanometers has a frequency of 10 to the x. The speed of the wave is 10 to the y, where y is greater than 3. Write an inequality in terms of in terms of x to represent all possible values of x. All right. So let's see what we have to do here. Speed is 10 to the y. Wavelength. Wavelength gives it to us the wave of the wave with the wavelength 10 to the negative third, so equals 10 to the negative third times frequency, which is 10 to the x. All right. Clearly, they don't want this. They don't want it to look like this. And I noticed that everything has a base of 10. So I'm going to write out one more step. 10 to the y equals. When you multiply two things with the same base, you add the exponents. So what I have is 10 to the negative 3 plus x, or x to the negative third. There's a rule that says if you have 10 to the stuff equals 10 to something else, that stuff equals that something else. So that leaves me with y equals x minus 3. Now, y has to be greater than 3. So this guy is y. This guy, x minus 3, has to be greater than 3. I can add 3 to both sides, and that gives me a final inequality of x has to be greater than 6. That was pretty brutal, pretty rough. Not a fan. And the best part about this whole thing is that's part C. We've got one more to go. The wavelength of a 7th wave is recorded. The wavelength is greater than 2 times 10 to the negative second and less than 5/100ths of a nanometer. Okay, write a possible wavelength in nanometers for the 7th wavelength. Write the possible wavelength as a fraction with the denominator 100. All right, so I want things with a denominator of 100, so I'm going to keep that there. I'm going to keep you the way you are. Now, 2 times 10 to the negative second can be written as 2 times 1 over 10 to the second, okay, which is the same as 2 over 10 to the second, which is 100. So I need something in between that number and that number with a denominator of 100. So that gives me 2 options. That gives me either 3 over 100, or that gives me an option of 4 over 100. Now, what I'm not going to use, and maybe they'd accept this, I honestly don't know, but what I'm not going to use is I'm not going to use that one, because that simplifies to 1 over 25. I'm going to go with this one as a possible wavelength because that is in between 2 100ths and 5 100ths, has a denominator of 100, does not simplify, and follows all of these requirements. Okay? So gross, but fun.